In this module, you will learn to perform different operations on events. We know that a sample space and its associated events are represented in the form of sets. Thus, like set operations, we can combine two or more events by using analogous set notations. Let's consider a sample space S and two events of S, A, and B. The basic algebra of events includes complementary event, event A or B, event A and B, and event A but not B. Let's begin with complementary events. The complement of an event A is the event consisting of all the outcomes of the sample space that do not correspond to the occurrence of A. It is also called event not A. The complement of A is denoted by A dash or A bar. Let's consider the sample space shown when a die is rolled. A equal to 3, 6 is an event multiple of 3. Clearly, for outcome 1, event A has not occurred. However, we can say that not A has occurred. Similarly, for every outcome that is not in A, we can say that not A has occurred. Thus, the complementary event not A to event A, or A complement, is 1, 2, 4, and 5. In general, complementary event not A can be written as A such that A belongs to S and A does not belong to A. Next event, A or B, is analogous to the union operation on sets. If events A and B are associated with sample space S of an experiment, then event A or B contains all the elements that are either in A or B or in both. It is denoted as shown and is read as A union B or A or B. In general, event A or B is equal to A union B, which is equal to A such that A belongs to A or A belongs to B. Consider the sample space shown where a die is rolled. Let event A be the occurrence of prime numbers and event B be the occurrence of even numbers. Now, event A or B can be obtained as shown. Let's look at another experiment where two coins are tossed simultaneously. The sample space is obtained as HH, HT, TH, and TT. Consider these events associated with S. Therefore, the outcomes of the events are obtained as shown. Now, event A or B is obtained as HH, HT, TH, and TT. Here we notice that event A or B is equal to the sample space of the experiment. Such events are called exhaustive events. Two events A and B in a sample space S are said to be exhaustive if A or B is equal to S. In general, events E1, E2, E3, and so on in a sample space S are said to be exhaustive if the union of all the events is equal to S. In other words, events E1, E2, E3, and so on are said to be exhaustive if at least one of them necessarily occurs whenever the experiment is performed. If events A and B are associated with the sample space S of an experiment, then event A and B contains the elements that are common to both A and B. It is denoted as shown and is read as A intersection B or A and B. Event A and B can be written as A such that A belongs to A and A belongs to B. Consider a sample space of rolling 2 dice. Let events A and B be associated with S. The outcomes of events A and B are obtained as shown. Now, event A and B can be obtained by identifying the common elements present in both the events. Let's consider another experiment where 3 coins are tossed simultaneously. The sample space associated with the experiment is as shown. Now, consider 2 events A and B. Event A is getting at least 2 heads. Event B is getting at least 2 tails. Therefore, the outcomes of the events are obtained as shown. Now, event A and B is a null set because there is no common element between A and B. This implies that both the events cannot occur at the same time, and thus they are exclusive to each other. Such events are called mutually exclusive events. 2 events A and B in a sample space S are said to be mutually exclusive if A intersection B is equal to null set or A and B are disjoint sets. In general, events E1, E2, E3 and so on in a sample space are said to be mutually exclusive if they are disjoint sets. However, some mutually exclusive events in a sample space are exhaustive. For example, getting even numbers and odd numbers in an experiment of rolling a die. Such events are called mutually exclusive and exhaustive. In a sample space S, if any pair of 2 events EI and EJ are disjoint, and the union of all the events is equal to S, then all the events are called mutually exclusive and exhaustive. If events A and B are associated with sample space S of an experiment, then event A but not B is the event of all the elements of A but not in B. It is denoted by A minus B and read as A but not B. Therefore, event A but not B is equal to A such that A belongs to A and A does not belong to B. Please remember that event A but not B is equal to the event A and B complement. Let's consider an experiment of throwing 2 dice simultaneously. Consider events A and B associated with the experiment. The outcomes of events A and B are obtained as shown. Now, event A but not B is the elements of A that are not present in B.